taken place on an upper floor of a residential building. Part A, as shown in the figure 1, a firefighter uses a fire hose to direct a stream of water at the burning floor of extinguish the flame. The nozzle of the hose is at height 1 meter above the ground and 10 meter horizontally away from the building. The stream of water is to be targeted at height of 6 meters above the ground. The nozzle makes an angle theta 45 degrees with the horizontal. The figure is not drawn to scale. Part 1. Calculate the initial speed V0 of water stream ejecting from the nozzle should have to reach the target. Neglect the air resistance. Take root 2 equals 1.4. We can consider that it is a projectile motion. Then this distance, horizontal distance is 10 meters. It is given in the question. And this point is 1 meter above the ground. Therefore, height of the projectile motion should be 5 meters. They have given total height from ground level to fire point is 6 meters. But fire hose 1 meter above the ground. Therefore, we have to consider projectile motion. For the projectile motion, vertical displacement should be 5 meters. And we know that projected angle theta 45 degrees. We have to find the initial velocity of projectile motion. Then I will mark initial velocity as u. Then we can get components of velocity. Horizontal component u cos 45. Vertical component u sin 45. Then we can use equations for the motion from A to B. I will use A to B horizontally. We know that there is an acceleration in horizontal direction. Therefore, horizontal displacement is 10 meters. Therefore, we can use only S equals ut in horizontal direction. We have to use S equals ut. S is the horizontal displacement, it is 10. Velocity component in horizontal direction, u cos 45. We don't know the time. Then I will subject time from this equation. 10 divided by u cos 45. I will mark this equation as first one. Then we know the vertical displacement. Therefore, we can use an equation from A to B in vertical direction. When considering vertical movement, we know that there is an acceleration. It is a constant acceleration in downward direction. Therefore, downward acceleration means we can get acceleration as a negative value. We are using equation in upward direction. We can use S equals ut plus half at squared in upward direction. S is the vertical displacement. Vertical displacement is 5 meters. Initial upward velocity u sin 45. U sin 45. Time is this value. We can use 10 divided by u cos 45. but when using this equation, it's okay. We can substitute cos 45 and sin 45 separately, or we can use that value for the final answer. I will simplify without substituting sin or cos value. Plus half into acceleration in downward direction, but we are using equation in upward direction. Therefore, acceleration is minus 10. T squared, square of time means square of this term. We can substitute 10 squared divided by u cos 45 squared. U squared cos 45 squared. We can write it cos squared 45. Then write in cos 45 squared, we can't write it like this. Because of this means 45 squared value, and we have to find cos value of that angle. We can write like this, or we have to write it in this format. Therefore, square of cos 45 means cos squared 45. Then we have to simplify this equation to find the u value. We can cancel out u and u in first term. Then 5 equals to sin 45 divided by cos 45 tan 45 into 10. This value 10. 2 divided by 2 1, 10 divided by 2 5, plus into minus minus 5 into 10 squared 100, it is 500, divided by u squared cos 45 value is 1 over root 2. Cos 45 1 over root 2. Then getting squared, we can substitute it as half. 1 over root 2 squared means half. Now we can cancel out all terms by 5. 5 divided by 5 1, 10 divided by 5 2, 500 divided by 5 100. Then I will get this minus term to the left hand side. 100 divided by u squared, 1 over root 2 squared is half. Tan 45 1 into 2. We have to bring this one to the right hand side, it is minus 1. Then we can get 2 to the numerator. 2 into 100, 200, divided by u squared equals 2 into 1, 2, 2 minus 1, 1. Then u squared is 200. U value is square root of 200. When getting square root, we can write it 100 into 2 root. We know that square root of 100 is 10. Root 2 value is given in the question, 1.4. Then u value is 10 into 1.4. It is 14 meters per second. It is the velocity, initial velocity of corresponding projectile motion. Right, then part 2. The internal cross-sectional area of hose is twice that of nozzle outlet. Calculate the speed V1 of water inside the hose and hose end before the nozzle. Assume the water is incompressible. We can use continuity equation. It means the hose is like this. Area of hose is 2 times of area of nozzle. 2 times of area of nozzle. And we know that velocity at this place should be this value. It is 14 meters per second. We have to calculate flow velocity in the hose. It is given as V1. Then we can use A1 V1 equals to A2 V2. Cross-sectional area for this one 2A V1. Cross-sectional area for this one A, velocity is 14. Then we can cancel out A and A. We can find V1 value 14 divided by 2. It is 7 meters per second. Flow speed in the hose. Then part 3. If the pressure of water inside the hose before the nozzle is higher than atmospheric pressure by a value delta P. Calculate the value of delta P. Assume that flow is steady and water is non-viscous. Neglect the vertical height between nozzle outlet and hose in just before the nozzle. Density of water is given as 1000 kilogram per cubic meter. We have to use the Bernoulli's principle between this point and this point. They have given that pressure of water inside the hose before nozzle is higher than atmospheric pressure by a value of delta P. It means we know that pressure at this point should be atmospheric pressure. I will mark it as P naught. Pressure at this point is atmospheric pressure plus delta P. There is a higher pressure. Then I will use Bernoulli's principle between this x point and y point, x and y. We can write P plus half rho v squared plus h rho g at x should be equal to P plus half rho v squared plus h rho g at y. Pressure at x, P naught plus delta P, half density of water is given as 1000, square of velocity, we know that velocity at this space is 7 squared. We have to neglect height difference between this point and this point. It means this vertical height is negligible. Therefore, if this level is the potential level energy zero level, we can consider that this one also at same level. Then we can cancel out h rho g. Potential energy zero level, x and y, both points are in the potential energy zero level. Then we can write right hand side, pressure P naught, atmospheric pressure, half density 1000, velocity for this space 14. We can write 14 squared. Now we can cancel out P naught and P naught. We have to find delta P value. Half and 1000 common factors. Then we can write 14 squared. When bring this term to the right hand side, we have to write it as a minus term. Minus 7 squared. Then we can get 2 divided by 2, 1, 500. 500 into, when simplifying these two terms, we can get it is different between two square terms. Then first bracket should be sum of these two values. 14 plus 7, 21. Then 14 minus 7, 7. Now we have to multiply it. Delta P equals, there are two zeros, 5 into 7, 35. Multiply by 21. 2 zeros, 21 into 5, 105. 5, 10 remaining. 21 into 3, 63. 63 plus 10, 73. We can write it 73,500 Pascal or 7.35 into 10 to the power 4 Pascal. Then part 4. The internal diameter of nozzle outlet is 2 centimeters. Calculate the volume flow rate Q for the water jet leaving the nozzle. Take phi equals 3. Then we can write volume flow rate is Q. They have given it as Q. Volume flow rate means volume divided by time, volume per second. Volume flow rate per second is product of AV. We have to find volume flow rate at nozzle. Therefore, we can write it is A2 V2. We have to substitute values. This one is a circular cross section. Therefore, we can write phi r squared. V2 value is 14. Then we have to simplify it. They have given that to take phi as 3. Radius is 2 diameter is 2 centimeters. Then radius 1 into 10 to the power minus 2 meters. We have to convert 1 centimeter to meter and we have to get to square into 14. 14 into 3, 42 into 10 to the power minus 4. It is 4.2 into 10 to the power minus 3 cubic meters per second. Right, then part B. A firefighter expects to reach the burning floor by climbing up along a ladder. As shown in the figure 2, a uniform ladder of length L and mass capital N rests on a rough ground at A with its top end against a smooth wall at B. The ladder makes an angle theta equals 60 degrees with the ground. The mass of firefighter is simple N. Assume that the firefighter is standing upright on the ladder at a distance x from A. Draw the free body diagram of the ladder and mark all forces acting on the ladder. Take in normal reaction forces at A and B and frictional force at A acting on the ladder as RA, RB and FA respectively. Draw a uniform rod for the ladder. We have to draw the free body diagram of ladder. Therefore, we have to draw only ladder. It is like this. Don't draw the man or any other object, wall or floor. Just draw the ladder. Then we have to mark forces. This point is B. Reaction at B is RB. It is a smooth connection. They have smooth contact. Therefore, there is no frictional force at B. This point is A. There is a reaction at A. It is perpendicular to the surface. But A is not smooth. It means there is a frictional force. We know that ladder is trying to slide in this direction. In this direction. It means we have to mark frictional force opposite to the sliding direction and along the surface. We know that this angle is 60 degrees. Then we have to mark weight of the ladder mass is given as capital M, then weight of the ladder capital Mg, and weight of the man simple Mg. He is at a x distance from the end A, from point A. It is the free body diagram. Then part 2. If the coefficient of static friction between ground and ladder is mu, by resolving forces and taking moment around A, derive an expression for the maximum distance x max in terms of capital M, simple M, capital L. Capital L means length of the ladder, and mu, that the firefighter can climb before the ladder begins to slip. We have to consider the situation corresponding to the limiting equilibrium. We can get for the limiting equilibrium, we can write frictional force is mu R, mu Ra. Ra means reaction at this point, mu Ra. I will mark this one as the first equation. Then we can write for the horizontal equilibrium, force in this direction Rb equals to opposite force Fa. And we know that Fa is mu Ra. Therefore we can write Rb equals, Fa means mu Ra. It is the second equation. Then we can get vertical equilibrium. For the vertical equilibrium, upward force, there is only one upward force, it is Ra, should be equals to sum of downward forces capital Mg plus simple Mg. Now there are three relationships. I will use these three relationships to substitute then solving problem by getting torque around point A. They have given that we have to consider torque around point A. In the question they have given it. Taking moments around A, derive an expression. Then I will get moment around point A. For the limiting equilibrium, counterclockwise torque should be equals to clockwise torque around point A. Then getting counterclockwise torque, there are two forces we have to consider. We know that this ladder is rotating counterclockwise by the torque given by capital Mg and simple Mg. Then we can write capital Mg into, we have to get perpendicular distance from point A to the action line of Mg. It means we have to get this distance. We know that total length of ladder is capital L. This one is L over 2. It is a uniform rod. L over 2 is the hypotenuse. We have to find adjacent. Then we can write it is L over 2 cos 60. Relationship between adjacent and hypotenuse. We have to write cos ratio. Plus torque due to simple Mg. Mg into perpendicular distance is this one. When getting it, we know that we have to consider this small triangle, small right angle triangle. Hypotenuse is x, adjacent is the problem. Then we can write it x cos 60. and there is only one force to rotate it in clockwise direction. It is RB. Then we can write it RB into perpendicular distance from this point A to RB is this height. Then getting it, if this angle is 60, this angle also 60. Hypotenuse capital L, we have to get opposite. Then we have to write sine L sine 60. Right now, we have to substitute RB value by using this equation. mg L over 2 cos 60 plus simple mg x cos 60 equals RB is mu RA L sin 60. Now I will divide all terms of the equation by cos 60. Then we can remove this cos 60. mg L over 2 plus, we can remove this cos 60. mgx equals to mu RA L sin 60 divided by cos 60 is tan 60. Then we can write mg L over 2 plus mgx equals mu. We know that RA value is this one, capital Mg plus simple mg. I will get g as a common factor. Then we can write g into capital M plus simple m. It is RA L tan 60. Tan 60 is root 3. Now we can subject x term. We have to subject x value. Before subjecting x value, we can cancel out g from all three terms. Then mx equals mu m plus simple m L root 3 minus this term ml over 2. Then I will get x value. We can divide all three terms by m. X equals to mu into capital M plus simple m L root 3 divided by simple m. We have to remove this simple m, therefore we have to divide all three terms by simple m minus ml divided by 2 simple m. It is the relationship. But then part 3, if capital M 20 kilograms, simple M 70 kilograms, capital L 6 meters, mu 0.3, calculate the value of x max. X max means maximum x value. We have obtained limit in equilibrium situation. Therefore, we can substitute given values for this expression and we have to find the x value by using that equation. Then I will get the derived equation. X equals mu value 0.3, capital M value 20, simple M value 70, capital L 6 meters, root 3 divide by simple M value 70 minus again capital M value 20, capital L value 6 divide by 2 into simple M value 70. Now we can simplify it. X equals 0.3 into 20 plus 70, 90 into 6. Root 3 value is given in the question 1.7 divide by 70 minus, we can cancel out 1 0 and 2. 7 divided by 6, sorry 6 divided by 7. We can cancel out 1 0. 9 into 3, 27. 27, 2.7. Multiply by 6 into 7, 42, 4 remaining. 6 into 1, 6 plus 4, 10. 10.2 divided by 7. Minus 6 divided by 7, 0. 60 divided by 7, 8, 0.8. I will get up to first decimal place. Then we have to multiply these two terms. 102, 27. 7 into 2, 27 into 2, 54. 5 remaining. 27 into 0, 0 plus 5, 5. 27 into 1, 27. 2 decimal places. We have to divide by 7. 27 divided by 7, 3. 21. 6 remaining. 65 divided by 7, 9. 3.9 minus 0.8. Then it is 3.1 meters per second. Sorry, meters. You have to obtain corresponding distance. It is meters. At the examination, they have given 3 meters, 3.1 meters. You can get full marks by getting that two answers, 3 meters or 3.1 meters. But in this question, they have specially given that give your answer to the nearest integer. Therefore, I will write it as 3 meters. Part 4. Firefighters places a special anti-slip mat under the ladder foot at A to prevent the ladder from slipping. The firefighter must reach the top of the ladder. Find the minimum coefficient of static friction between the mat and ladder must have using the expression derived B2 above. Give your answer to the nearest 2 decimal places. Again we have to do same thing, but now we have to substitute x value as the length of the ladder. He has to reach from this end to this end. It means total moving distance is equal to the length of the ladder. Length of the ladder is given as 6 meters. Then I will use this equation again. But now we know the value of x is 6 meters. When simplifying part 4, we have to remember that x should be equals to L, it is 6 meters. Then we can write x value 6 equals, mu is the problem, capital M mass of the ladder 20 Simple M, mass of the man 70. Capital L value 6, root 3 1.7. They have given in the question in previous one. Simple M 70 minus capital M 20, L 6 divided by 2 into simple M 70. Now we have to simplify it to find the value of mu. 6 equals mu into 20 plus 70 90 into 6 into 1.7 divided by 70. We can cancel out 0 and 0. 2 divided by 2 1. 1. 6 divided by 7 we have obtained in previous calculation. It is 0.8. Mu 9 into 6 54. 54 into 17. 7 into 4 28. 2 remaining. 7 into 5 35 plus 2 37. 1 into 4 4. 1 into 1 1. 8 11. 1 remaining. 3 plus 1 4 plus 1 5. 5 1 8. There is only one decimal place. Divide by 7 minus 0.8. Then I will bring minus 0.8 value to the right hand side. Sorry, 0.8 to the left hand side. 6.8 multiply by 7 divide by 51.8. 7 into 8 56. 5 remaining. 7 into 6 42 plus 5 47. One decimal place. 47. Divide by 51.8. 476 divide by 518. 0. It should be 9. 9 into 8 72. 7 remaining. 9 into 1 9 plus 7 16. 1 remaining. 9 into 5 45. 45 plus 1 46. Then minus 2 8. 15 minus 6 9. 98 remaining. It is approximately 0.91. Now answer of this one should be 91.8. Then we have to divide it by 91.8. Then we can obtain answer 0.51. We have to give the answer to the second decimal place. They have asked to the second decimal place. Right, then part C, as shown in figure 3, another firefighter uses a rope and pulley to go up and rescue a person. The pulley with radius 0.1 meters is fixed to the crane of the fire tank and light inextensible rope passes over it. The firefighter is attached to one end of the rope and other end is pulled by a constant force 960.5 Newton by a motor in the fire truck. The mass of the firefighter with the rescue basket is 80 kilograms. The pulley rotates freely and the rope does not slip on it. you have to remember that rope does not slip on the pulley. The moment of inertia of pulley about its rotational axis is 2.5 into 10 to the power minus 3. Part 1, determine the linear acceleration of the firefighter. Now we have to remember there is a friction between pulley and rope. It means the pulley will rotate. There is a friction between pulley and rope. Therefore, the pulley will rotate. If the linear acceleration of firefighter is A, tangential acceleration of the pulley also A. We know that this force is 960.5 Newton and force in this direction, it is 80 kilograms, mass 800 Newton. Now I will mark tension. When marking tension in rope, we have to remember that tension in this side is a different value than this side. This side tension is 960.5, but we can't get this tension as that value because of pulley is rotating. For a rotating pulley, there are two different tensions in both sides. Especially pulley is accelerating. Therefore, I will use 280 kilogram mass, F equals ma in upward direction. Upward force tension minus downward force 800. Mass 80, acceleration is the problem. I will mark, I will subject T equals 80A plus 800. It is the first equation. Now we can use tau equals I alpha to the pulley. Tau equals I alpha. It is accelerating. Torque is 960.5 is the supportive force to rotate, and we have to subtract opposite force. It is the resultant force in tangential direction, and we have to multiply by the radius of the rope, so radius of the pulley. Force into perpendicular distance. Now I have considered resultant torque. When getting resultant torque, we can get 960.5 into R minus T into R. Because of T into R is the torque in opposite direction. Moment of inertia of the pulley is given as 2.5 into 10 to the power minus 3. We can substitute alpha by using this equation. We know that A equals R alpha. Then alpha equals A divided by R. A divided by R. Now we can substitute T value by using this first equation. 960.5 minus T value is 80A plus 800 into radius of the pulley is 0.1. 2.5 into 10 to the power minus 3. A is the problem. Again radius 0.1. I will write it as 10 to the power minus 1. Now we can solve this equation and we can find the value of A. (960.5) minus into plus minus 80A minus into plus minus 800 should be equals to, we can simplify 10 to the power minus 1 and 10 to the power minus 2. Then 2.5 into 10 to the power minus 2 means 0.025. I will bring this 0.1 to the right hand side as a division. Then 960.5 minus 800, 160.5. When dividing by 0.1, we can multiply it by 10. It means 0.25A. I will bring 80A to the right hand side as a plus term. 80A. Then 80.25A equals 160.5. Then we can subject A value. 160.5 divided by 80.25. It is 2 meters per square second. Linear acceleration of the man. It is equal to the tangential acceleration of the pulley. And then part 2. If the system starts from rest, calculate the angular speed omega and rotational kinetic energy K of the pulley after 3 seconds. Now we know the linear acceleration of the pulley. It means tangential acceleration. We can find angular acceleration by using that value. We can use A equals R alpha. A is 2, radius 0.1. Then we can find alpha value is 20 radians per square second. Radians per square second. Then we can use omega 2 equals omega 1 plus alpha t. It is like V equals U plus AT in linear motion. Omega 2 is the problem. Omega 1 0, alpha 20, time 3 seconds. It is 60 radians per second. 60 radians per second, final angular velocity. Right, then we can use kinetic energy equation, rotational kinetic energy equation to find the kinetic energy. Half I omega squared. Half into moment of inertia is 2.5 into 10 to the power minus 3. Omega value is this one, 60, then 60 squared. 2 divided by 2, 1, 60 divided by 2, 30. 2 zeros, 3 into 6, 18, 18 into 5, 90, 0, 9 remaining, 18 into 2, 36 plus 9, 45, 1 decimal place. And 10 to the power minus 3. It is 4.5 joules.